Thank you for joining us today on our vCops overview. This is going to be a two-part series, and this is part one that you're watching right now. Part one and part two are not dependent of each other, so it does not matter the order that you watch these videos in. You're welcome to watch them in whatever order you prefer and whatever is going to be helpful to you. With that, in this first part, we're going to review an overview of the badges for vCops, as well as a little bit of the environment and some operations overview. And in part two, we're going to go over some planning detail. So with that, let's jump right into it. Let's jump into vCops and how it can be helpful for you in interpreting the badges, interpreting the data, and understanding what is it trying to show you here. So the easiest thing with vCops is to start to understand what's the interface. And the interface is a left-hand column here that's navigation of your elements, from your individual vCenters to a world object that might represent all of your vCenters, down through your data centers, your clusters, your hosts, your VMs, and your data stores. The center window here, which we're on the dashboard screen right now, is actually where you see all of your details. And we're going to dive into several of these tabs through this series of videos that you're going to be watching here. And then also on the right-hand side is an overview of alerts and the badge scores repetitively as well. So beyond this introduction of vCops, let me also introduce myself. My name is Jim Silvera, and I am a solutions architect focusing on vCops from a pre-sale standpoint with VMware, and have been doing so for the past 2.5 years, and have been in the industry for about 20 years at this point. And I will be taking you through this presentation of vCops today. So badges. Badges are really a helpful way for you to interpret and understand what's going on in your environment. So instead of looking at raw values and scores and metrics, badges are a way that you can get some human intervention to understand what should I be paying attention to. And the badges are across three primary areas, and that is health, risk, and efficiency, and these are known as major badges. These major badges are derived from badges that you'll see in a few moments here that are below them. So health is all about here and now. Why do I focus on what I'm going to focus on right now and possibly wake somebody up at 3 o'clock in the morning? And risk is all about midterm planning. And efficiency is all about long-term planning. So risk would be midterm planning is what do I do over the next few days or a week? And efficiency is all about what do I do over that longer period to maximize and make sure my environment is running effectively. So let's focus on health. And if we want to know why our health score for this cluster is a 52, we're going to expand the why is health 52, which should be pretty obvious here. Most people miss these buttons or don't really notice them, but also why is my risk a 49 and why is my efficiency a 36? So starting with health, health is made up of workload, anomalies, and faults. So workload is how hard am I working right now across 4 key areas: CPU, memory, disk I/O, and network I/O. It shows the range that I'm normally in, and then where am I now. We can see that our workload score is a little elevated because we're working a little harder than we normally do for this time of day in this environment. Specifically, it looks like across CPU and across disk I/O. Anomalies are, of all the incoming metrics, how many of them are deviating outside of a term considered normal. And you can see here where we have this gray line that represents what is the total quantity of noise. One or two metrics deviating is not a big deal, but a series of them really does become a big deal. And that's really trying to determine what that line is that breaks that threshold for you to really be concerned about it. And the important concept here is that we use analytics to do this. So using the analytics, we can start to understand what that normal behavior is for this time of day, this day of the week, this week of the month, etc. And we can understand what those learn cycles are. And then the final item are faults, and faults are errors and alerts coming directly out of vCenter, things like disconnected disconnected storage or disconnected redundant NIC, those types of things. That's all well and good, right? What do these mean individually, and how do they apply to you in your IT environment? But I find an easier way to explain these is actually to use an analogy. So to use an analogy very quickly, we'll say that instead of monitoring your IT environment for health, we're going to monitor me. And in monitoring me, we're going to actually suggest that I'm going to go run on a treadmill today. And for the sake of argument, we'll say that I run on this treadmill every day of the week for an hour a day. But today, I'm going to bring my physician along to see how I'm doing running on this treadmill. So as I start running on the treadmill, my workload obviously increases. I'm working harder than I do any other time of day. Running on this treadmill is more output than what is normally happening any other time of day. But running on a treadmill is going to cause this workload to increase, but it's also not going to see any anomaly behavior either, because running on this treadmill is normal behavior. Even though my heart rate has increased, my breathing has become labored, and I've started to sweat, those are no big deal things. They're expected for running on the treadmill. I'm also not generating any faults because I have no errors or any alerts going on for running on the treadmill. It's normal behavior. I'm in good shape. There's nothing to be concerned with. My doctor even tells me so. He says, keep it up, Jim. That's good work. You'll be nice and healthy by continuing to run this treadmill for an hour a day. But what he can also see in doing this analysis is the example of these blue bars here. Am I trying to show off? Am I running harder than what I normally do when I do this workout on a daily basis? So you can see whether I'm running in normal ranges or exceeding, right? And if the metrics that are the output are anomalous. So on the other hand, I'm no longer running on this treadmill. I'm now sitting on my couch. It's nice and cool, relaxed. My physician happens to be there with me. And as I sit on this couch, all of a sudden my heart rate increases, my breathing becomes labored, and I start to sweat. My doctor's now going to look at me and say, what's wrong? That's not really expected. What's going on with you? And what he would see is that I would have high workload because those increased metrics are causing the higher workload. But he's also seeing anomalous behavior now, and the anomalies are on the rise because this is unexpected for this situation. And he's also probably seeing faults or errors or alerts for this as well, because I'm generating alerts saying that I'm on the verge of having a heart attack considering the situation. So the fact of seeing all three of these now says I have something to look at. And this is really, again, that important concept of why we use analytics. If this was an older generation tool that was all about the raw metrics themselves, both of those situations would have generated the same quantity of alarms and alerts for you to pay attention to, saying that you have a problem. One would have been inaccurate for the fact that I was just running on the treadmill, and the other would have been accurate for the fact of having a heart attack. But because of using analytics, we can tell the difference between the two, and we can actually tell you one is not something you should be concerned about, yet the other is. And that's why it's really important to use badges and understand what these badges are, which are a quick and simple concept for me to understand where do I focus and what do I focus on. So moving from health, what we want to do is move over to risk. And risk is about some additional badges here as well. So the badges that we have under risk are time remaining, capacity remaining, and stress. So I like to cover these as two separate topics. The first topic being time remaining and capacity remaining. And they go hand in hand. You can think of them as different axes on the same chart. There's an x-axis and a y-axis on a bar chart, one being capacity remaining, the other being time remaining. And for the fact of this example, let's say the capacity remaining was not 14 more VMs, and we'll get into the why and how do we understand these scores here in the second half of our video that I mentioned in this two-part series. But the capacity remaining, let's say this said 1,400 VMs. And looking at this cluster, I would say, wow, that's a lot of capacity that's remaining. But what I really want to understand is not only is that number high, but how long is it going to last me? So if I had 1,400 VMs and said, wow, that's a lot and that's good, if I was to run out of that tomorrow, that would be bad. So time remaining is that understanding of how long is it, not only, how many more do I not only have, but how long is it going to last? So we can see in this example here for this cluster, based off of our current usage, we have about 14 more VMs left, and that's going to last us for about 75 more days. So the final item here is stress. And we can see in this environment that we have quite a bit of stress, especially with all the yellow here. But what it looks at is each day of the week for each hour of the day over a 6-week average. It actually shows you that right here. And what stress is doing is looking directly back at workload. So that an analogy that I mentioned earlier of running on the treadmill for an hour a day. Let's say this was a lot more green than it was yellow. Let's say at 3 o'clock in the afternoon, I ran on the treadmill for an hour a day every day. There was a nice bright red spot there saying that there's a lot of workload going on a regular basis. This would be the equivalent at 3 a.m. you running your backups in your environment. I'd see that hotspot, I'd understand that there's a hotspot there, but it's probably not something I'm going to react to or respond to because I'm not really worried about it. It's expected. On the other hand, I have these brighter hotspots here that are happening throughout the entire day, and I have this high workload that's going on a regular basis. Going back to my analogy, let's say I get done running on that treadmill for an hour a day. Doctor, as I said earlier, said, keep it up, Jim, that's good, you'll be nice and healthy. I make a self-diagnosis after he leaves and decide that it'll be really healthy if I run 18 hours a day on that treadmill instead of an hour a day. Do this for a while, suggest that I could. And I call my doctor with great news. Hey, guess what? I'm running 18 hours a day. He's going to look at me and go, you're a damn fool. You're going to kill yourself. Same concept here. When am I putting that undue stress and those long duration workloads in my environment that I really need to be concerned about? And that's exactly what stress is showing you. So moving on from stress, we're going to move over to the efficiency column here. And efficiency is really about two different items. One's reclaimable waste, and the other one is density. And density is pretty straightforward. It's what's that VM to host ratio, what's that vCPU to CPU ratio, and what's that VRAM to RAM ratio. Shows you where you are, gives some optimizations and recommendations on where it believes you should be. And obviously, you can go out to vCenter and directly impact these scores and directly impact what the density of your environment is. Let's suggest for now we're not going to do that. We're going to use the density score as a reference mark that we're just going to pay attention to and keep track of. And more importantly, what we are going to look at, though, is the reclaimable waste. And again, with these planning type capacity-related scores, we're going to cover them in a lot more detail in part 2. But with reclaimable waste, it's looking at what is the idle VMs in the environment, the powered off, the oversized. This really has an immediate ROI out of vCenter operations that a lot of customers can see some great benefit from. First and foremost is that sprawl that most virtualization customers experience, right? The need for more storage resources, the need for more host resources and hosts themselves. And how do I get that under control, especially with the business continually asking for larger and bigger and more resources in the environment. It's never ending, it seems, with virtual environments that they believe that it's free and that they can have as much as they want. It's just virtual, but we all know that that comes with cost. So this reclaimable waste allows me to understand where can I reclaim that and maximize that investment that I currently have. Beyond that, I see another important point here, and that's using some of the other inherent technologies that many of you are already using within your environments, and that's things like DRS, and beyond DRS, high availability, right? But with DRS, I set a ratio of what's that ratio of acceptable workload to be able to move from hosts for the VMs. And if it's a 1-to-4 ratio, for example, and I can expect a single host failure, I leave open slots that things can slide into and DRS can move things automatically to those remaining hosts. Well, it's not the easiest ratio to set in the world because of the differing size workloads and VMs I have in my environment. And if I don't get it right, what happens is VMs get shut down and human intervention needs to intercede, and I get these workloads that are actually shut down and have direct impact on the business. So reclaimable waste has a really important impact here that if I can get that under control, I can do a better job of setting what those ratios are for DRS to work more effectively. So this really does have a couple impacts, not only in dollars and cents, but how well am I leaving myself from being vulnerable of those workloads not having to shut themselves down and human intervention having to happen. So these two scores make up the efficiency score. So all in all, you can see here that the badges help you make quick decisions and understand what's going on in the environment, but how do I use them? How do I use these badges as an overview to act upon and maximize my environment? And I've coined a term here, and that term I've coined is working backwards. It's pretty simple, pretty silly, but I think it makes an accurate point. And the point is, as I mentioned, health all about here and now, so most people would say, well, Jim, shouldn't I just start there? My point to them is, no, let's not start there. Let's actually start out in the efficiency column and look at how these badges all work together and how I can use them to help build a more proactive environment that I have less reactive issues happening in and I have better control over. So starting in the efficiency column, the first thing that I would do is probably work with the reclaimable waste badge. Clicking on it will take us over to the planning tab and allow us to start working with these idled, powered off, and oversized VMs, and allow us to run the reports and the interactions to be able to start making the judgments of what to reclaim there. And let's say we do reclaim that waste. And reclaiming that waste to the best of our ability is going to improve the score, but it's also going to inherently improve our density. So I mentioned earlier, density was something I was just going to pay attention to. Because in performing this action, it's going to have that direct impact, and I'm going to start to improve these density scores just from that interaction. And in turn, this is going to improve my efficiency score since it's driven by those. So by doing this first action reclaimable waste, I've cleared this entire first column. But what I've also done is improved my capacity remaining and also improved my time remaining, which has further improved my risk score. So in doing this very first action, I really cleared half of the board here. So the second action that I would do is really focus on the stress column. And stress, by clicking into it, will also take us to the planning tab. And this will focus on our undersized VMs, the ones that are probably not sized correctly on the other side or opposite of the reclaimable waste. And what we'll do is we'll use some of that regained capacity, not all of it, but since we have reclaimed it, we don't need to worry about going and acquiring more, but we're going to use some of it to help maximize this stress badge. So in doing this, I've now taken care of this entire risk column as well. But what I've also done is improved my workloads by reducing that stress, which has also slightly improved my health. And it's also reduced the likelihood for anomalies and reduced the likelihood for faults by making sure that my environment is really maximized and configured accurately. So I've really, by taking these two steps, maximizing the scores on this board and really paying attention to my environment, I've built a more proactive environment that I have less reactive issues in and better control. So now I'm dealing with less ongoing issues on a regular basis, phone ringing and fire alarms going off, and I have a better controlled environment. But just because I moved to this proactive state and this product helps me do so, it does not eliminate the reactive nature of the environment. Things are still going to go bad. The phone's still going to ring. But now what I can do is I can focus on this health column and look at, is this guy just running heavy on the treadmill right now? Or is he sitting on that couch having a heart attack that I really have something that I need to worry about? And in just a few moments here in this first part, we're going to dive into some examples of how would I respond to those type of issues. And you'll see that here in a few moments. So all well and good, this dashboard's fantastic. It's focused on the element I've selected here. In this case, we're looking at a cluster, but if I want to look at the score for a host, I would click on a host and the scores would be relative to it. Well, that's not really helpful because I really want a better overview of the environment and what do I really pay attention to if I was to look at this tool on an ongoing basis. And what I would suggest is, even though the dashboard gives this collaboration of what that all represents, I would suggest that maybe what you want to look at is the Environment tab. So the Environment tab, depending on the item I have selected, will shadow to the front what are the related objects related to this cluster, for example, and really shadow to the rear what are the objects not related to it. So you can see where the highlighted is all of the objects related to the cluster, and the shadows behind the fact are all related to objects that are not selected and don't have relationship. What this also does is allow us to minimize this navigation pane and maximize the real estate on the page. So now I can hover over items that might have some high scores and start to look at what's going on here. So we can see for this object here that we have that degrading health due to a high workload and some anomalies that are going on. But I can also change the perspective here. We can start to look at this from a risk perspective or the detail of time remaining or stress or one of the efficiency-related badges. Or instead of just health itself, look at it from a workload perspective and start to look at what's the relationship there. And you can also see as we change objects, we also get that relative information related to the objects. So actually, let's look at the details of some issues that we're having in this environment. I know that from having previously worked in this environment, and just to keep this video short and give you some perspective, that I do have a VM here that is not responding very well. It's having some issues. My SQL Analytics VM. By clicking on it, you can see that relationship. We can see that he has some very high workload. His workload is working at 160%, and that's really due to some disk I/O issues. Whether I double click on him here or I get a quick overview of what's the relationship across the dashboard, but clicking on any health-related badge or double clicking on any health-related badge from the Environment tab will take me to the Operations tab. And in looking at the Operations tab, I can see exactly what I was talking about a moment ago. We can see that the workload is very high. It's running at 160%. And we see that 160% is for disk I/O. And we see for the disk I/O that actually the disk I/O is outside of what its normal operation is. We can see that that's running really high outside of what the normal expectation is here. And again, we get that detail over here as well from looking at workload. So the curious question is this happening all of a sudden, or has this been happening for a while? So looking at key metrics, we can look at disk I/O metrics, and I can see via that gray band what the normal range for this is. And we see that that spike happened just all of a sudden. In drilling this up, I have the ability to look at this in more detail as well, and you can see where that spike has happened just all of a sudden looking over this past 6 hours here. And that gray band is what we're talking about for analytics and the learned behavior. It puts things in perspective. It helps me understand what is that normal, and if it's outside of normal, starting to raise those alerts and alarm me that things are going on. So that's how we can put it in perspective. And the way this learns is over a 3-cycle period. First time it sees something, it says, all right, this is new and unexpected, and if it hasn't evaluated normal, it just is still learning normal. Second time it says, all right, I've seen it before, but I'm not sure. And third time it does say that it's normal. But if we were to lose the gray band here, we would still be able to see that this spike happened. There's something to respond to. So the reason that I point this out is I have many customers come to me and say, well, Jim, it hasn't learned yet. Should I just wait longer? No, actually use the data. You can see that, hey, this is what it's been performing like, and all of a sudden it changed. I should probably look into that in more detail. We just lose that perspective of what normal is if we haven't been monitoring for all that long, or if it's unexpected new behavior. So again, the question becomes, is the phone ringing? Is somebody complaining? Yes. Well then, hey, let's look at what is changing. Or no, the phone's not ringing. All right, I see this, but let me go check it and make sure everything seems okay. Yeah, everything seems okay. I don't really have anything to worry about. So whether or not it's actually taking the cycle to learn, you can still use this data to troubleshoot issues. So if we scroll down further, we can look at relationships, and we can see that, yeah, the host is having some actually peer objects, so these are the other VMs around it, but the host is also having some high workload from the parent object. And we can see that here, that the total throughput for the host is 435 I/O commands and 136,000 on the KB per second. We can see for this VM that he's running 419 commands, and he's using 135,000 and 136,000. Wow, for this disk I/O issue, it's not really a host issue that I'm dealing with or a data store. It's the fact that this VM is doing something, and what the heck is going on this SQL Analytics VM. And we could drill into all metrics and the details of all metrics, and we can look at events that are going on here. And in reality, when we look at this object here, it's really the fact that we want to be taking advantage of even more advanced capability in vCops, and that's the ability to consume metrics from tools like Hyperion and SCOM and other sources that we can look at the application data because something's going on in the SQL VM. But that's how I can start to troubleshoot and see where and what do I need to pay attention to. I know that I need to drill in deeper on this SQL VM to find out what's causing all that disk activity. In the case of this example, it was an Arab batch job that was running on this SQL server. So with that, I'm going to end this first part. Hopefully that's a nice introduction for the folks watching this video of what do the badges mean to me, why are the badges so important, and how do they help me interpret what's going on in my environment. Understand that environment tab that gives you the better overview of trying to understand the relationship of objects and get that honing in on where my problem spots I should be looking at, as well as drilling into the operations tab for me to understand how to start to troubleshoot issues. With that, have a great day, and I hope you enjoyed watching this video.